Hi everyone, welcome back to Mathematics for Engineering 3. In the last video, we talked about it's an introduction. We talked about what the differential equations are, right? And we talk about types of differential equations, the ODEs, the PDEs, right? And then linear and non-linear differential equations. And we also talk about the orders, right? How do we know the orders of the differential equations, as well as the solutions? How do we know that this equation is actually the solution of the differential equations? And the last thing we talked about last time was the how to convert the usual differential equations into the differential forms, right? So today we are going to talk about a new thing, which is the separable equation. It's a special type of differential equation. When the differential equation is separable, we have a way of solving it. Okay, so let's start. Okay, this topic we are going to solve the special type of differential equations called separable equations. So, what are separable equations? If you look here, the first order ODE in this form is a differential form, right? Is called separable if it can be written as this. So, uh, what's the difference of this? This you can see here the coefficients of x and y, they can be functions of x and y, right? But the ODE is called separable if the coefficient of x contains only x. See, it's only x, and the coefficient of dy has only y. So if you see differential equations in this form, the coefficient of x is only x, the coefficient of y has only y, that ODE is called separable. Make sense? And if the ODE is separable, you can find the solution by that, just integrate throughout the equation. So the solution of the equation star is actually the integration. And if you integrate, you would get a constant here, right? C is any constant, right? So if you look here, if you integrate, you can integrate this. It's the integration of function of x by x and the integration of function of y dy. So those are integrable, right? At least if you know how to integrate them. And you have got a constant here. Note the constant c here is any number. C here is any constant. Okay. Let's look at this example. If you look here, find the general solution of x plus 2 dy minus 3y dx. But as you can see, if you don't remember, you just write the separable equations here first. So it's ax dx plus by y equals 0. So in front of dx, they are only x. In front of dy, they are only y. Okay? But if you look here, it's a little bit different, because in front of y, in front of dy, they are x. But in front of x, they are y. It's a it's a little bit different, but so is it it is separable, is it? It is. It is. You just need to manipulate this differential equation a little bit, and then you will see that it's actually separable. How? First I'll call this equation star. So first I will divide the whole equation by x plus 2. So I'll get that is dy minus 3y divided by x plus 2 dx equals 0. And then I'll divide this double star by y. So I'll get that is 1 over y dy minus 3x plus 2 dx equals 0. See, right now you have a differential equation where in front of dy you have only y, and in front of the x you have only x. So this is now looks separable, right? So to solve this ODE, you just need to integrate throughout the equation. So if I integrate this differential equation, this is what I get. Guys, don't forget the constant, okay? Don't forget the constant. And then if it's pretty simple. I'm not gonna be teaching the integrating of functions, okay? Because you have learned that from math 1 and math 2. Those are just calculus basics. But if you don't understand these integrations, just text me, okay? Ask me like how how I could write this integration. Just ask me how did I get the solutions, okay? But I'm not gonna be focusing on the integration parts. So the integrate of 1 over y is actually log of y, log of absolute y. And usually you just need to plus c1 plus the constant, right? And the integration of 3 divided by x plus 2 is actually log of minus 3 log of x plus 2. Yeah, and need to plus another constant, and this is equal to the constant c. So this is actually the way, but to be honest, guys, c1 is some constant, right? This is another constant, and this is another constant. We don't actually know what the value of c's are, right? We don't know c1, we don't know c2, we don't know c. So those are just constant. So usually we just put them together. Okay, just put them together. Just put this c1 into c, c2 into c, and we still call it c. Okay, so normally we won't write this equation. We won't write it. Okay, we will just write it as log of absolute y minus 3 log of x plus 2 equals c. Okay, because the c1 and c2 are included in C. Okay, because they are just constant. They are just constants, okay? And if you want to stop, you can just stop here. All right. But if you want, the solution, this is the solution. Okay. Just in case you don't know, we have already had the solution. This is solution. The solution of differential equations must not contain the derivative. Okay, that's the whole point, because we have the differential equations containing derivatives, right? So if we solve them, the solutions must not contain derivative. See, there are no derivatives here. So to make it look a little more beautiful, it is log of y plus log of, right? Log, right, from your high school. You can just put minus 3 here, up here, so it's going to be minus 3 here, equals C. And the sum of the log is log of y times x plus 2, and you have it's a log of y divided by x plus 2. And to use the the property of log, you have that e to the c, right? You can just push the log up here to be the exponential, right? That's from high school. Okay guys, now it's a little tricky, because first we have e to the c, right? But e is a constant. E is a constant. It's actually 2.7 something, blah blah blah. So it's a constant. Constant, to the constant. So this guy is actually another constant. So I'll just call it C star. And we have an absolute function here. So guys, just to go back to high school, if we have absolute of x, it's actually x when x is positive, right? And is minus x when x is negative, right? That's the definition of the absolute. For example, if x is 2, the absolute of 2 is 2, isn't it? Because 2 is positive. Okay? But if x is minus 2, the absolute of x will be minus of x, which is minus of minus 2, which is 2 as well. Right? Right? We use this case because x is negative. So just to sum it up, if x is positive, absolute of x is actually x. But if x is negative, the absolute of x, you need to put another negative sign in front of x. Okay, guys, I'm running out of space, so I'll just reduce the size here so that I have some space too. So I just put these guys here. Okay, guys. So now let's look at this guy. It can be either positive and negative, right? Right? It can be, I mean, the thing inside here. It can be both positive and negative. So what I'm saying is that it can be either y divided by x plus 2 cubed, right? We just get rid of the absolute. In case, just in case that is in the case that is positive. And in the case that is negative, it would be minus of y divided by x plus 2 cubed, right? Because, you know, if the thing inside positive, just get the thing inside. But if the thing inside is negative, right? If the thing inside is negative, you get the minus of the thing inside. Make sense? Make sense? So for the first case, we will get that is y divided by x plus 2 cubed equals c star, right? For the positive case. And for the negative case, we get that is minus y divided by x plus 2 cubed equals c star, right? But how about if I multiply the whole equation by minus 1? So I'll get that is equals minus c star, right? So it's equal minus c star. But guys, c star is a constant, right? So if c star is a constant, minus of c star is actually another constant, right? Right? We don't know what c star is, we just know that it's some value. So it's a constant. So if I put the minus sign there, it's just another constant. I'll call it c double star, right? So from here, from the absolute of y divided by x plus 2 cubed, you can see that in case that is positive, you get this equals to some constant. In case that is negative, you get that this equals some constant as well, right? So what I'm saying is that from here, you can just take the absolute out, because in either case, you will get this equals some constant, right? It can be c star, it can be c double star, but doesn't really matter because they are just constants, right? They're the same thing. Okay, so then I can just take the absolute out. So this is what I get. I can call it c triple star, right? It's just some constant. You can name it whatever you like. You can name it c with the 5 stars if you want. Okay. So that's the solution. That's the general solution. So then y divided by x plus 2 cubed equals c triple star is a general solution of this guys. Okay, that's it. So just to sum it up here, guys, if you have the absolute of something, okay, just for you to memorize it, if you have the absolute of this equals constant, guys, it's really important that this side is a constant. Okay, so if you have this equals constant, you can just take absolute sign out. Why? Because if it's positive, you get this equals constant. If it's negative, you get this equals the minus of this constant. But so what? It's still a constant. Okay, so if you get the absolute of something equals constant, just take the absolute out. Cool? Cool? Okay. This example. Does it look separable to you guys? It doesn't look quite separable to me. Okay? Okay. But if you look a little more closer, let I factorize these expressions first. Up here you have that is actually x minus 1 and x squared plus 1. Sorry, y squared plus 1. Right? You can do the factorization, right? X multiplies x times y squared is actually xy squared. X times 1 is actually x, and minus y squared and minus 1. Oh, sorry, I the equation is wrong. So it's actually minus 1 here. My bad. Sorry. Actually minus 1. So the denominator is, just do some factorization, is x minus 4 and y minus 1. Right? If you multiply here, it's xy, and is minus x is minus 4y and plus 4. So this is the factorization. So after factorizing it, does it look more separable? It kind of does. Okay, to make it even clearer, I'll write it in this way. So this is not differential form, right? This is the usual form, right? So to write it in differential form, we will have that dy is x minus 1 y squared plus 1 divided by y minus, and I push dx to this side. Makes sense? I push dx. Okay. Don't forget, guys. Dy by dx is y prime. Dy is actually y prime. Okay. Or you can just look at y prime as, some box. If dy by dx is a box, dy is actually the box times dx. So you have dx here. So to make it looks separable, I will just move these terms to the left hand side first, and then I'll get that is y minus 1 divided by y squared plus 1 dy equals x minus 1 divided by x minus 4 dx. Make sense? And then is separable, okay? Because in front of dy there are only y's. See, no x at all. In front of the x there are only x, no y at all. Okay, so to solve this differential equation, you just need to integrate throughout the equation. Right? So this is the integration of function of y dy, the integration of function of x dx. So you're supposed to be able to integrate these, functions. So it's kind of like you go back to calculus 1, right? To how to integrate the functions. So if you can't integrate them, you can't do this course. See, that's why you need to learn the integration first. So if you don't know how to, this is a good chance. Okay, so I'll look at each integration individually, and I'll put them back together again for simplicity. So I'll look at this integration first, and this is actually the integration of y squared plus 1 y minus integration of 1 over y squared plus 1, right? Make sense? So to integrate this function, first I'll let you be y squared plus 1. So du is actually 2y dy, right? So right now I'm looking at this integration first. So I'll multiply 2 and divide it by 2. So the 2y dy is actually du. Make sense? The 2y dy is actually du. So I'll have that is 1/2 of integrate 1 over u du, right? Because I let u be y squared plus 1, so y squared plus 1 is actually u here, and 2y dy is actually du. So this is what I have. Make sense? It's the integration by substitution. And then the other one is the integration of 1 over y squared plus 1. This one, it is, if you can remember, is arc tan y. Okay, I'm not writing a constant term because they are going to be included in this C, so I won't be writing the constant terms. Okay, so we'll have that is half of log of u minus arc tan y, which is half of log of y squared plus 1 minus arc tan y. But y squared is positive, right? Y squared is always positive. Y squared plus 1 is still positive as well. So you don't need the absolute function. So just get rid of absolute. Okay? Because it's always positive. You don't need to put the absolute there. Make sense? Make sense? So the other one, the integrate is for dx. So what I'm doing is, I'll do this: x minus 4, x minus 4, and then I plus 3 here. This is the same thing. X minus 4 plus 3 is actually x minus 1, isn't it? Nothing changes, right? Right? And then this, these are the techniques of integration. So if you have problems with integrating these functions, you probably want to go back to the calculus 1 and look at those materials, because you really need to do some integrations in this course. And I have that is the x minus 4 dx plus 3x minus 4 dx. And this is just 1, isn't it? So the integration of this would be x, right? The integrate 1 to get x plus 3 log of absolute x. So I'll plug in this up up I'll plug in this and that in here, right? So I'll have the solution, which is, so the solution is half of log y squared plus 1 minus arc tan y equals x plus 3 log of x minus 4 plus c. Make sense? It's hard. So it's probably hard because you don't know how to integrate this function and that function. But actually our course ends here, because as soon as we can write this as a separable ODE, you just need to integrate them, and that's it. After that is back to calculus 1, right? It's back to how to integrate them, right? But the new thing that you're learning is to change the differential equations into the separable forms. It's not a good word to use the word changing. It's not changing. It's already separable, but it's hard to see, right? So you need to manipulate the term somehow to so that you are able to see that it's a separable function, separable equations, and then you just integrate, and after that it's just calculus 1. You need to get them. Okay, the next topic is initial value problems. So the initial value problem is the same as the problem that we have been looking at. They are the same thing, except that for initial value problem you have one more condition. This one. See, if you don't have this, it's the same, right? Find the solution of this. It's the same thing. But for the problem to be called initial value problem, you have one condition. You have a initial condition, which is x0 and y0. You basically have one point. X, if x is 2/3, y would be pi divided by 3. So this is the same as to say that x0 is 2/3 and y0 is pi divided by 3. Okay, so this is called initial condition. And if they give you the initial condition, the solution no longer contains the constant c. You'll see later when we do the computation. But we call the solution a particular solution. Okay, we call the solution a particular solution, not a general solution. So you can use this condition to get rid of c, to get rid of the constant term. Find a particular solution of this equation where y of 2/3 is pi divided by 3. Okay, this is the initial value problem. So you can find a particular solution, right? Not only the general solution. So we'll see how to do that. First, we'll need to look at the differential equation first. It's not okay. It could be separable, but it's unclear. It's very unclear because first, it's not even in the differential form, right? So we'll change that first. Right? And as you can see, you still have dy by dx, and it's not in the differential form yet, right? So, so to change that to differential form, I have this, right? It's the same as to to multiply the whole thing by dx, and the dx here cancel out, and you have the dx here. Make sense? It doesn't work that way, as I told you, okay? I am a mathematician, so I shouldn't suggest you to look at it that way. But for simplicity, and you are engineers, okay? For simplicity, just look at it that way. It's much more simpler, okay? And right now, it's still not, okay, it is, but it doesn't look very separable, right? Because in front of dy, you have y. But in front of the x, you have x and y, not only x. So, change that, I will divide the whole equation by sec of 3y. So this is what I get. Two x dx equals 0. Make sense? And right now, it looks separable because the in front of the y, they are only y's, right? And in front of the x, they are only x. Is that clear? So to solve this differential equation, we just need to integrate, right, throughout the equation. So what I have here is integrate y cos 3y dy minus integrate 2x dx equals c. Make sense? And then I'll just look at this integration first, which is the integration of 2x dx, and this is pretty easy to integrate. I'll look at this one first. This one is actually 2x squared divided by 2, which is x squared. That's it. So we have left with this integration. So we need to integrate y cos 3y dy. So how should we integrate y cos 3y dy? Do you remember? For this one, the multiplication of polynomials and trigonometry functions like sine, cos, we need to use integration by parts. Do you remember how to do so? The integration by parts. Well, if you don't, I'll teach you how. To do integration by part, so I'll just do it here. Integration by part, I'm going to do the quick method. No, I'm not going to do the full method. This is the quick method. So you split between u and dv, right? You need to choose which one is u, which one is dv. So the trick is, if one of them is polynomials, if it's y squared, y to the y cubed, or if they are polynomials, they are likely to be, okay? So the function that you can dip, you can find the derivative easily, those are u. And the function that you can integrate easily, those are tend to be dv. Okay, so here you will get y, right? Because you can differentiate y, and this is cos of 3y. And on one side, you keep differentiating, and on the other side, you keep integrating. So dy is actually 1, and then it's 0, right? Right? It's dy by dy, by the way. And cos of 3y is actually psi of 3y. Right? You know how to do so? The integration of cos 1/3 of psi. Sorry. Sorry. Right? And then you do the integration again, you get minus 1/9 of cos dy. Okay? For those of you who can't integrate cos 3y, we'll get back to that. But for now, just believe me that integrate cos 3y is actually 1/3 of psi 3y. So to find the derivative, you draw the diagonal line here. So one is plus and minus and so on. If you have the third term, it will be plus minus plus minus. And the solution of this is y times 1/3 of psi 3y minus 1 times minus 1/9 of cos y, cos 3. Make sense? You multiply this, and then you get the plus sign. And you multiply this to this with the minus sign. You get the. Make sense? Then, okay. And then you have that this derivative is one-third y psi 3y plus 1/9 of cos 3y. Okay, so guys, if any of you is not familiar with the integration by parts using this method, just come and talk to me. Okay, I can give you some more examples, or I can explain to you what it is. Okay, just text me. We can talk about that. Don't leave it. Okay, you are gonna need to do it at some point in the exam. Okay. Okay, so let's get back to this. Why is the integration of cos 3y is 1/3 of psi 3y? This can be done by the integration by substitution. So if I let u be 3y, so du is actually what? 3 dy, right? So the integration of cos 3y dy, I'll multiply it by 3 and divide it by 3. So the 3 dy is actually du. Make sense? Make sense? 3 dy is actually du. And I still have the integration of cos 3y is actually u, right? 3y actually u. Sense? And I have 1/3. But the derivative of sine is cos, so the integration of cos is sine, so that's why you get 1/3 sine of 3y, right? It's sine u, but sine u is actually sine 3y. Okay guys, again, if you aren't able to do these integrations, just need to go back to the calculus 1 and look at the materials, or you can just text me and we can talk about that. Okay, so I will erase these because they are not here. So I'll plug in the integrations back into this equation. So what I have is 1/3 y sine 3y plus 1/9 cos 3y minus x squared equals c. And this is actually a general solution, right? It's a general solution. But what we need is actually a particular solution. Actually a particular solution. But we know that y of 2/3 is pi divided by 3, right? Or in other words, x0 is 2/3 and y0 is pi divided by, whenever x is 2/3, y would be pi divided by 3. Guys, this is not y times 2/3, okay? It's not y times 2/3. It's a function y when x is 2/3. Okay, so we need to use this initial condition, right? This is called initial condition. We need to use this initial condition to get rid of c, right? To get rid of c. Okay, how? Okay, I'll get another page because it's too long. Here, just copied what we had. How? So I just plug in y as pi over 3 and x as 2/3. So I'll have here pi sine of 3 times pi over 3 plus 1/9 of cos of 3 pi over 3 minus 2/3 square equals. Make sense? So basically I just plug in y equals pi divided by 3. So wait here. See, there's a y. And I plug in x as 2/3. which is here, right? And then what I have here is pi divided by 9. This cancel out, so we are left with psi pi, but psi pi is actually 0. Psi pi is 0, so we have 0 here, plus 1/9 of cos pi minus 4. Okay, cos pi is minus 1. So what we have here is minus 1/9 cos minus 1/9 minus 9. Okay, so we have that c is minus 5 divided by 9. So we can now get rid of c because we already know the value of c. So the particular solution is 1/3 of y psi 3y plus 1/9 of cos 3y minus x squared equals, so we just basically substitute c here by minus 5 divided by 9, and this is called a particular solution. That's it, right? So to find a particular solution, you need to first find a general solution, and then you plug in the initial condition, right? X is what, y is what, and then you get the value c, and then you replace the c here in the general solution by the value c that you get from the initial. That's it. Easy, isn't it? Okay, the next question. Find the particular solution of this differential equation where y of 0 is 0. So here, as you can see, here it doesn't look separable, but it's pretty easy to make it separable. So what I can get here is x divided by x plus 1 dx equals what is it, 1 divided by log of y plus 1 dy, right? I get rid of this by dividing everything by 1 minus x, right? Oh, sorry, this should be 1 minus x, and then I get rid of this by dividing everything by y plus 1. Make sense? So now it's separable. Cool. And then the solution is integrate. I'll use the blue. Integrate of x 1 minus x dx equals integration of y plus. That good? And then here is the integration of x minus 1 plus 1 . Okay, let me look at each integration individually. This one is actually I'm looking at this one first. I'm looking at this integration first. Okay, so this one is can I do this? x, and then I minus 1 plus 1 divided by 1 minus x dx. Nothing changes, right? I just minus 1 and plus 1. Nothing changes. And then it's actually integration of x minus 1 minus x dx plus 1 minus x dx. Right? Right? And here it minus x 1 minus x dx divided by 1 minus x plus. Make sense? Right? I just pull minus 1 out. So if you multiply it back, you will get this x minus 2. So what I have here is minus integrate dx plus integrate 1 over 1 minus x Cool. Okay, then that integration is minus x, right? Plus this is integration of 1 minus x d 1 minus x. So you will need to have another minus here. So I'm doing the integration by substitution for this term. Okay. Okay. So here I'll get that is minus x minus log of 1 minus x that cool? And for the other term, the integration of 1 divided by 1 plus y plus 1 dy is this one is actually this part. It is log of y plus 1, right? And do the integration by substitution. Get log of y plus 1. So if you plug in everything, you will get the general solution is minus x minus log of 1 minus x equals log of y plus 1 plus c. And then if you want to find a particular solution, you would need to use this initial condition, which means that x0 is 0 while 0 is 0 as well, right? By the value of c. I'll move this into the next page. So to do that, I'll substitute x by 0 and y by 0 as well. So I guess minus 0 minus log of 1 minus 0 equals log of 0 plus 1 plus c. But log of 1 is always 0. So this is 0. This is 0. So you get that c is actually 0. Make sense? So your particular solution is minus x minus log of 1 minus x equals log of y plus 1, because c is 0. Does it make sense? And if you want to make it look more beautiful, you can just write it this way. Minus x is log of 1 minus x plus log of y plus 1. And this is log of 1 minus x times y plus 1. So you have that e to the minus x is absolute of 1 minus x times y plus 1. Can we take the absolute here out? I told you before that the absolute of something equals constant. We can just remove the absolute, right? So you get this equals constant, right? Why? Because this is just a constant. So if this is positive, you get the c, right? If it's positive, you can just remove the absolute. If it's negative, right? If it's negative, you get minus c. But minus c is also a constant, right? So it doesn't really matter. But guys, here, this side is not a constant, right? We already get rid of the constant, see? So here, it's not a constant anymore. So it's not the case where we have the absolute equals constant. So in this case, we can't really take the absolute sign out. Make sense? So we will just answer that the particular solution is just this. So we won't take the absolute sign out. Make sense? Okay guys, that's it for this video. So just to sum it up, we have been talking about separable problems, right? Right now we know whether or not the ODEs are separable, right? If the things in front of the x has only x and the things in front of the y has only y, that ODE is called separable, right? And to solve that, you just need to integrate throughout the ODE. But the hardest, I think probably the hardest thing is to actually integrate those functions, right? But that is in Calculus 1. So I would recommend you to go back to Calculus 1 and to to brush up a little bit, right? To look at the techniques for integration, right? The by parts, the integration by substitution, and I don't know, the partial fractions, and those kind of things. So you probably better if you can go back and look at those techniques. Okay, so that's it for today. In the next video, we're gonna be talking about the differential equations, another type of differential equations which are not separable. So if they aren't separable but they are so-called homogeneous, so what we can do about that? So next time you know what homogeneous is, and you can solve even more problems in differential equations. I know that I'm trying to make it I don't know, interesting, even if it's not that interesting, but guys, you still need to do it, okay? So just enjoy it. So see you next time. Bye bye.